is Mia, and today I'm going to give you a presentation of COVID-19, a brief review of SARS-CoV-2. Are you guys excited? Yay. Moving on. Oops, I'm sorry. Why is my... Oh, okay. So the objective of this presentation, the purpose of this presentation is a brief review of viral origin, identification, replication, transmission, symptoms, and prevention strategies for a newly identified SARS-CoV-2 strain. And moving on. So before we start our presentation, I want to give a brief vocabulary so you guys will be familiar with some words. So COVID-19 stands for Coronavirus Disease 2019. Community spread means people have been infected with the virus in the area, including some are not sure how or where they became infected. Zoonotic, a disease that normally exists in animals, but can be transmitted from animals to people. Incubation period, we hear a lot about incubation period, but do we really understand the meaning? The meaning is the period between exposure to an infection and the appearance of the first symptom. Endemic, a regularly found disease among particular population or in a certain area. For example, you guys heard about the malaria, right? Ebola in Africa, so it's endemic. Epidemic is an outbreak of disease that attacks many people at about the same time and may spread through one or more communities, for example, smallpox or H1N1 strain. And pandemic, that's where we're here today. It's when the epidemic outbreak spreads throughout the world. Do you guys got it? You guys got it? Awesome. Moving on to another slide. Okay. So I want to give a little background. What is a coronavirus? Because coronavirus became so popular in 2019. So coronavirus was first isolated in 1937, but first human coronavirus was cultured in 1960 from the nasal cavities of people from the common cold. On the left side, okay, Joey, I have a quick question. How do I pop that little, I can use like a laser or something, the red dot so I can point. Do you guys? Do you guys see my error here?
Yeah, they can see your
okay.
mouse moving.
Okay, the red dot, Okay, so on the left, okay, back to my slides. On the left side, you guys see the real-time picture of coronavirus. So this is how it looks. This is how it looks. And there is 4 categories of coronavirus are known. It's alpha, beta, delta, and gamma. And only 2 strains, 2 categories that known to infect people are alpha and beta. And oops, oh my gosh, what happened? Okay, 1 second. Okay, sorry. Okay, almost here. It always happens to me. I'm not good with technology still, guys. Bear with me. Okay, perfect. So, do you guys know the name coronavirus originated from? It's from the Latin name, from the Latin word corona, meaning crown, due to its characteristics and appearance. If you look back here on the left side on a picture, do you see those little spikes coming out of the coronavirus? Those are S protein spikes that gives that little appearance of corona. And it came from the Latin word corona, crown. So here we go, we learned something new today, right? So coronavirus have those club-shaped spikes protein covering their surfaces. You don't see really the club shape here, but those are the spikes that makes the corona appearance. The most known viruses are MERS-CoV, SARS-CoV, and SARS-CoV-2. Moving on to the next slide. Do you guys have any questions so far? Joey, any questions? No? Okay, perfect. Here, I want to give I really like this picture because it really shows you all coronaviruses that we have as of today. And the main one, we're gonna pay attention on this coronavirus. Do you guys see it? this is the pathway how it actually originated and transmitted to humans. So there is the first outbreak in 2003 happened that in China, and it came from domestic animals, but the origin source was the bats, from bats to domestic animal and then to humans. The second outbreak was in 2012. I'll double check. It's a Middle East Respiratory Syndrome MERS outbreak in Saudi Arabia, and it came from the camel. It was the intermediate host. The region was originated in bats, but then it was transmitted to camels and from camels to human beings. And here we go, COVID-19 outbreak originated in bats, and it was transmitted to there is no like study to confirm that, but there is a theories by scientists that it was transmitted as an intermediate host to pangolin and then to human beings. Any questions so far? Okay, perfect. Moving on. And here I want to give a little brief statistics according to the WHO about the previous two coronavirus outbreaks that happened in SARS 2003 and MERS 2012. So SARS killed about 10% of 8,096 people in 29 countries. A total of 774 people died. Second outbreak in 2012, MERS killed more than 30% of 2,494 confirmed cases in 27 countries and killed total of 858 people. It's a huge numbers, right? If you look at it. And here we go. Here we're gonna start paying more attention on our new outbreak, COVID-19. So severe acute respiratory syndrome 2, SARS-CoV-2, is the official virus that causes the COVID-19. First identified in Wuhan, Hubei, China in December 2019. The majority of patients were diagnosed with atypical pneumonia and had links to the Wuhan seafood market. Source of origin, question marks. We don't have a confirmation from scientists that it really originated in bats, but we have a theory that bats are the primary source. Current evidence supports that human transmission occurred via transmissions from wild animal illegally sold in the Huanan seafood wholesale. And it had a rapid spread. The data shows a doubling every 7.5 days. And on January 30, 2020, the WHO declares a public health emergency of internet. Again, I went back. Sorry. Okay.
Mia, real quick.
Yeah.
Arlene has a question.
Oh, okay.
Why does it seem that bats are the primary hosts, and what makes them the host interest?
That's a good question. So in 1937, if we go back to that slide, right? Okay, if we go here, right? Coronavirus was isolated in 1937. It's just bats are just in natural, they have that virus and they're asymptomatic, which means they live with the virus circulating in their blood. So there is no like the real study. They're studied about the bats to prove why they're a good host, but hopefully in the future. So I don't know if I answered your question, but it was a very good question, which I don't really know how to answer. But this is what if you trace back to the history, this is where they're isolated and the bats are the primarily host. Did I answer the question?
Yes.
Erin. Yeah, okay. Okay. And so we stopped here. So and it has been declared a pandemic by WHO in March 2020, which is recently. Any questions so far? Nope. Okay. And my philosophy, I always say, learn your enemy. So we're gonna learn our enemy by looking at the anatomy of the virus. So here, do you see the picture here, right? The whole virus. So I highlighted the main three components. They're very important, which is the envelope protein, facilitates assembly and the release of the virus. And you can see the envelope protein here, the yellow protruding proteins. And another important one, it's a spike protein, S. Those are here. If you see those red spikes, club-shaped spikes, right? What they do, they mediate attachment to host receptors. They attach to our cells in the lungs. And another important one, nucleocapsid protein, which packages the encapsulated genome into the viral particles. So those are nucleocapsid protein. They cover the RNA. They're here. So this is how the coronavirus, COVID-19, looks like. Pretty cute, right? Any questions before we move? No? Okay. So next slide, I want to talk about the replication cycle. We're going to touch a little bit biology here. So what's happening? So the first, when human being inhales the droplets with coronavirus, SARS-CoV-2, what's happening? The first binding and the viral entry with membrane fusion or endocytosis. If you see here, the coronavirus, what it does, the S protein spikes, they attach to the ACE2 receptors on a host cell. And what it does, it allows the hijack our cell and let the virus enter inside the cell. What's happening next there? It releases the genome. And the SARS-CoV-2 has single-strand positive RNA. What it means, positive RNA means it imitates the messenger RNA, so it can start the replication right away by using the host ribosomes. So it's quickly starts its replication. It doesn't need to go from DNA to RNA to proteins. It has a positive single-strand RNA, which makes it more faster to replicate. So it goes through a couple steps to produce the necessary proteins to assemble of the mature virion. If you can see here, those like S, E, and M proteins that I mentioned in the previous slide. So positive RNA translates and produces those proteins and then assembles those proteins into the mature virion. And from there, it exocytoses our cells and bam, it's ready to go and infect another cells in our lungs. Pretty clear? Do you guys need more explanation, more questions? So you guys got it. But the main question is, yeah, we touched the biology of the coronavirus, COVID-19, but the main question is how it really spreads. I like this nice picture that allows you to see how it spreads the novel virus. What's happening? The virus spreads mainly from a person to person through the air by coughing and sneezing. You can see a person here coughing and sneezing improperly. And what coronavirus droplets, when coronavirus droplets ended up in the air, it can travel from 1 to 2 meters, approximately 5 to 6 feet, right? What it can, then from there, it has 2 different pathways. The droplets containing viruses in there can directly enter to the nose or mouth or eyes, or the droplets fall on the surface objects, and then you or someone else touches those objects, they can transmit those viruses into the nose and mouth. So virus can hang out as a droplets in the air for up to 3 hours before they fall. Transmission occurs through respiratory droplets or else through contact with the contaminated surfaces, as I mentioned, and viable particles may remain on stainless steel and a plastic up to 72 hours. So that's why it's important to disinfect the surfaces. And incubation period may vary from 1 to 14 days, and the average incubation period ranges from 5.1 to 11.5 days, and the report came from China. And the risk of transmission from asymptomatic person is low, but still possible. Do you understand the word asymptomatic? The person with no symptoms has a low rate of transmission, but still it is possible. Okay, and here we go. We have a little mini quiz for you to see how you know the coronavirus. Aaron, I think you have to, Aaron? Joey, are you?
Yeah, Erin, if you could launch the poll on the Zoom right on the bottom. While we wait for that, do you want to answer some of the questions that are in the group chat, Mia?
Oh, yeah, let's do that. Yeah, I like questions.
Okay. Jordan is asking, how does mRNA vaccine work in disrupting the replication process?
Oh, that's a good one. Okay.
You can also see the chat on the bottom.
Okay. Is there? Oh, okay. I think I hear. Chat. Sorry. How does the messenger vaccine work in disrupting the replication process? I don't know. I'm not too sure how it works specifically, but I can actually find that information, and I can put in a little. I can put in a word and just maybe email later on, because I have to research and read more about it. Then if this how
Yeah, sorry, it was a hard question. I was
Yeah.
just wondering.
But
hard
it's a good question. No, I like
like-
it's a good question. It's a very good question. Thank you,
It's
Jordan.
just like hard to find information online that's like clearer.
Yeah, I totally understand that. And sometimes they put such a smart paper, you know, like articles that you read and you really don't understand. Sometimes it takes for me to read a couple times before I'm like, oh, okay, now I got it. So it's okay. I'll try to do my best. And maybe by the end of today, I'll maybe send it email to Joey and she can share with you guys. But this is a very good question, because so far we don't have any vaccine for the novel virus, right?
Yeah.
Okay,
Okay,
next
thank
question.
you.
Is this how virus works? How would you essentially cure people? Oh my gosh, you guys are so smart. You guys are having such a cool questions. Okay, let me go back to replication and let's think together. Okay. If this is how virus works, how would you essentially cure people? And now there isn't many drugs right now. They've been showing the potential, but we're not too sure yet because we didn't do enough research, right? So when I read, my understanding was it would be nice to inhibit those receptors. See those receptors? So the virus wouldn't enter inside, or inhibit the RNA replication, or inhibit the S protein spikes here. So there's many different ways that scientists can approach that. So hopefully soon we'll get something as a treatment. Next question, Brayden. But for COVID-19 is not airborne, right? Like, is it possible? It could be possible. Yeah, definitely. Because there is again, it's a novel virus. We don't have any solid answers yet, but it's totally possible they could be airborne. Hopefully it's not. Okay, next question. Since if you call the representative, the next person. It could, yeah, because it's it's in the droplets. So that's how it transmits, in the droplets. So the virus is in the droplets when you cough. So I actually, thank you, Arlene. It is airborne, my bad. It's not aerosol yet. We don't know if it's an aerosol. I'll explain that word too. There's two different ways how it spreads, but not the coronavirus. Like measles, right? You guys heard about the measles and TB, they're aerosolized. So I'll explain. I supposed to put that in the vocabulary. Okay, I'll put in the vocabulary additional words, but those are good words. Awesome, thank you. Okay, are we done? Okay, with the questions. I can hide the question Zoom. Okay, and back to polls. Okay, oh my gosh, you guys are awesome. Yeah, the COVID-19 stands for Coronavirus Disease 2019. Good job. You guys did awesome. Okay, how can I close the poll? Aaron, you have to close or me?
Can you try click the poll button, and then if not, I'll ask Erin.
Oh, okay, I did it. Awesome. So quiz time and moving on. So we talked about how it spreads, and next we're gonna talk about the symptoms. What are the symptoms? COVID-19 symptoms have ranged from mild to severe illnesses and death. Common symptoms are fever, mostly like 99% are presented as a fever, dry cough, difficulty breathing, or shortness of breath. But there is other symptoms present too, like fatigue, headaches, chills, sputum production, nausea, and vomiting. And some carriers may have no symptoms at all, but others can develop acute respiratory distress syndrome and lead to the death. And in 81% of cases had non-pneumonia and mild pneumonia. Pretty clear, right, with the symptoms. High fever, dry cough, difficulty breathing. I got this, next slide, I got this, oh, I got the poll. Okay, let me close that. Okay, so you guys see the beautiful graph, right? On the left side, on the vertical axis, we see the number of hospitalization, ICU admissions, and deaths. And on the x-axis, we see the group age. So what we see here, it's the coronavirus disease 2019 by the age group in United States from February 12 to March 16, 2020. What I want to really pay attention is in a dark blue color represents deaths. And you can see at age group of 85 and higher has the more deaths versus 0 to 19, 0 deaths. 20 to 44, there is a couple deaths, and it goes on. And here, oh, we have a question, Joey, if you wanna. Any questions here? It just beautifully represents the comparison of the age group and how coronavirus affects. And this graph was obtained from CDC from February 12, March 16, 2020.
Okay.
Do we have a question, Joey?
Question, yeah. So far, which pandemic in history is the most similar to the coronavirus outbreak? How does this compare to influenza?
Okay. As I mentioned before, this pandemic, I'm gonna go a little bit back so we can go back to the slide. We had a similar pandemics in 2003 and in 2012, SARS and MERS, which is the same virus family, coronavirus family. And how it's compared to the influenza, that's a good question. You guys have good questions. I have to do more research to see the comparison. What we see here now, it spreads faster, very faster, and it affects not only, it affects mostly people 85 and up. So hopefully, okay, so with the influenza comparison, I'll look more into it, and I'll email to Joey. Okay, Joey, so you can share with them. Can we save those questions? Right? I think so. Oh, Joey, I cannot hear you.
I think, yeah, I think I can save the group chat messages.
Yeah, if you can, that would be easier to give a more proper answers. But yeah, the pandemic in the history most similar, it's like SARS in 2003 and MERS in 2012. And SARS occurred in China and MERS in Saudi Arabia, which was mostly same pandemic. It affected 98 countries. And in 2012, it affected 27 countries. Okay, is this true that the COVID-19 is mutating continuously? Any viruses with RNA as a genome mutate continuously. If you look at the DNA and RNA, DNA tend to have less mistakes during the replication versus RNA. Same as influenza, it's an RNA, right, virus. And same with the HIV, it's an RNA. Same with the coronavirus, it's RNA. It will continuously mutate, but not at the point that it's gonna be something severe, because we don't see here the huge mutation. It's gonna take for a while to see like something serious with the coronavirus mutation. That's why it is airborne, or was it always? I think it was always airborne. That's how it was transmitted. If we go back to this slide here, it was always airborne, because I don't like looking at this picture. I don't know the camel could eat bats. I don't know about it. So it's mostly like an airborne transmitted at some point. Okay, why is there more mistakes with messenger replication than with DNA? Because DNA is more, we're going back to science. So DNA is more stable versus RNA. RNA is not stable, so RNA will tend to have more mistakes. And it's all about the polymerase and all enzymes that DNA carries. Oh, that's a good one, Erin. Can the bat potentially bite the camel? Everything can happen. I don't know. It might be a potential too. So another question from Arlene. So if we find a vaccine for this COVID-19, it will be very effective, at least for this 2019 version. Yeah, it could be very effective. It depends what kind of vaccine we're gonna have, and you guys heard on news, it's gonna take at least 8 months to 12 months, right? At the highest speed. Usually it takes a couple years. It depends again how fast the scientist gonna come up with this vaccine. Good, the bad. Okay, so we're good with the questions. We can move on, right? Thank you. Oh, okay, from the bottom picture with the red and cow, what is that? It's just a different type of the coronavirus. There's 7 or 8 strains that we know right now, and potentially alpha and beta. Those are, I assume it's the alpha and beta viruses, alpha and beta strains that can cause potential illness in human beings. So those, the coronavirus, we know they can be transmitted from humans to, animals to humans. Yeah, so those are different. Those are not very well known, because we never had a pandemic with those viruses. That's the more, in the red boxes, those are the main ones that we had in 2003, 2012, 2019. Make sense? Yeah. Okay. So coronavirus has existed for a long time. Yes, let me go here. If you can see here, Tiffany, it was isolated in 1937. So it existed for a long time, but who knows, maybe it was existing even before that. It's just when we humans as a scientist try to investigate and isolate and see that virus. And the first human coronavirus was actually cultured in 1960 from nasal cavities of people from the common cold. Make sense? Clear? Any questions? So why has this strain specifically caused pandemic? That's a good question too. I don't know how to answer this question, but I really like this question. And I'm gonna probably do more research about it. Why has this strain specifically caused a pandemic? Let's research about it, and Joel, you will email them back, okay? I'll do my homework today. I didn't know you guys are gonna have such a smart questions. You guys are super smart. Okay, so I'll do my homework after this presentation, and I'll try to find the legitimate information, such as scientific articles, and try to explain. And Joey will email you guys back. Okay, moving on. No more questions? Okay, we're gonna move on. Where we stopped? Okay. Quiz time. So you guys clear with this graph, right? Just showing you the difference in hospitalization, ICU admissions, and deaths in the different age groups. Going to a different one. So here I want to talk about, and again, this table I obtained from the CDC as updated as of March 26, 2020. So this table shows the risk factors. So the main risk factor we all know is the age, right? The data from China suggests that COVID-19 deaths have occurred in adults aged 60 years and above. And people with another risk factor, people with serious underlying health conditions. Those conditions could be diabetes, cardiovascular disease, or asthma, or some chronic disease. And the preliminary data in the United States indicates the fatality rate was highest in people aged 85 and above. If we look here, case fatality age, you see the number is high versus, for example, from 0 to 19 age group, right? 0 case fatality. Here it's more case fatality. So the highest risk factors group is elderly people and people with serious underlying health conditions. Any questions on that? Moving on. This is the most updated information of pandemic COVID cases reported in the last 7 days. I obtained that from World Health Organization as of March 26, 2020. And I bet you if you check today, the numbers will be different. So globally, it's almost 500,000 confirmed cases. And in parentheses here, it's the new cases in the last 24 hours. You see the numbers, they're high, right? And 20,834 deaths. And new cases in the last 24 deaths, it's 2,400. Then we look at the Western Pacific region, 99,000 confirmed cases. European region, 250,000 confirmed cases, and so on. In African regions, almost 2,000 confirmed cases. This is just showing you the situation in numbers globally, how the new coronavirus affects human beings globally. The numbers are very high. And if you see here, the United States, you see the United States, it's a dark color. We're reaching almost to more than 50,000 cases. Any question with that? No, clear. This is the US map. I wanted to show you how it affected and spread in US. You can see here dark color, dark red, I would say. And this is the New York State affected the most, meaning has 5,000 or more cases. Then it goes to Washington State and California. Hawaii, so far, we are under 51 to 100. And and my mom, actually, she lives in Washington State, in Vancouver, Washington, and they've been on quarantine for a long time, and the whole city is just shut down. No one is on the street, nothing. And if you go outside, you'll be fine with the 5,000, I assume, or I'm not too sure the total amount, but that's what my mom said. Everything is just like, the town is a ghost town. Any questions with this slide? And this is Hawaii. We're here. We're bright. We're not dark color, but hopefully we'll stay. Okay. And moving on to a different slide, I want to pay a little bit more time here. Flattening the curve, Aaron's favorite saying. Do you guys have you guys heard about the flattening the curve? No, yes, okay. So this is the model that we scientists use to show how we can, as a community members, can affect the transmission of the coronavirus, novel coronavirus. If you look at the image, you can see two curves, the blue one right? And the yellow one. And you see the dotted line. Oh, we have a question. And we see the dotted line here, how many very sick people hospital can treat. That's the limit. Okay, let me answer the question. We have a question. Joey, can you open it? Okay, where is that? Oopsie. Can you read the question for me?
I think it's not a question. I think Aaron just said hashtag lower the curve.
Oh, okay, gotcha. That's his. Thank you, Aaron. You're awesome. So there's two different curves version of that might happen in the United States, depending on the next steps as community can do. So the tall skinny curve here is bad. It means that a lot of people will get sick at once in a short period of time because we don't take enough steps to prevent the virus from spreading from person to person. So it can spike suddenly. Now, number of sick people, if we don't take steps to slow the spread, that's what the blue curve represents. I have 3 more questions, Joey. Do you want to read them? So we don't.
Michaela says, where are we right now? I heard that we haven't seen the worst of it yet.
Yeah, the prediction, what I read, the prediction is the end of the April. We don't know the specific date, time to be prepared and get ready, like, oh, the spike is going to happen tomorrow. Let's get ready. But they predict it's by the end of the April, it will see the worst. Yeah. Another questions? Oh my, let me open the chat.
Oh yeah, it says, Tiffany says, aren't we already over capacity in terms of how many sick people hospitals can treat?
Not at this point. I think we only have under 100 confirmed cases in Hawaii Island. So I'm not too sure if we really had hit that over capacity yet. That's what we're saying. It could happen by the end of the April. I mean, in places like New York. Yeah, that's a good example is Italy. Look what's going on in Italy. They hit the overcapacity a long time ago. They have to make a decision to whom to provide the treatment, even though they have a lot of sick people, right? With the severe illnesses. I'm very concerned how this is affecting the economy. I saw the news and it's not looking like tourists will reach the baseline again. That's a good concern because we all have that concern because so far no one is working. We just quarantine ourselves. And Julian, since there is no specific antiviral treatment for COVID-19 at this time, how are patients who are hospitalized currently being treated for COVID-19? That's a good question. Basically you rest, hydration, and let your body to fight the virus. And I think in a hospital, they just provide this the treatment, just the basic treatment for the flu to relieve the symptoms if you have a high fever, and probably IV to hydrate a person with the electrolytes, because we don't have a treatment confirmed as of 2020 to treat COVID-19. Any other questions? Hopefully soon we'll come up with some treatment for COVID-19. But so far it's just the basic treatment. Okay, moving on. Okay, oh, I have another question, right? Oh, okay, no, so I'm closing it. Okay, so moving on. Where we stop? With the blue curve. So the faster the infection curve rises, the quicker the local healthcare system gets overloaded beyond its capacity to treat people, as we are seeing in Italy, like we discussed before. In Italy, more and more new patients may be forced to go without the ICU beds, and more hospitals may run out of the basic supplies they need to respond to the outbreak. However, we know most people won't get sick enough to need a hospital, but those who do could overwhelm the number of beds and care teams that our nation hospitals have available. The flatter, we see the yellow curve, right? It's more flatter and it's under the dot line. So the most flatter, the lower curve is much better one, but it will take working together to make it happen. It's not gonna happen overnight. We have to come up as a community to prevent the transmission, to see that yellow curve in Hawaii. A flatter curve, on the other hand, assumes the same number of people ultimately get infected, but over the longer time of period, not as we see in here in a blue curve, right? It spikes rapidly. Here we see it's the longer period of time. A slower infection rate means a less stressed healthcare system, fewer hospital visits on a given day, and a fewer sick people being turned away. So we can handle that especially the hospitals and healthcare professions. So the good example to understand that two curves, for example, let's say in your school or at workplace, you have bathrooms and bathroom has only many stalls, right? Certain stalls. What if all students ran to the bathroom at the same time? What's gonna happen? It's gonna have a problem, right? Boom, the bathroom stalls won't have enough capacity, right? But what if the same number of people need to go to the restroom, but spread over the several hours? So the bathroom stalls will have enough capacity to take different students, right? Do you guys understand the example, like using these two blue and yellow curve, right? Any questions? We have a question. Oh, two more. Okay, let me open. And hydroxy is being used and works for a lot of people, but not suited enough to gain. Yeah, Aaron, the hydroxychloroquine is being used. Yeah, you're right, but there is no enough study. So we don't know if it really treats or not. We need more study. There was rumors that China's recorded patients were getting reinfected. How true? To get a reinfection, it's possible. Again, it's possible, but it would be less than mild symptoms. Same as you be infected with different viruses. It happened. It could happen. It could happen, but I don't think it's gonna be super severe symptoms. It would be less than mild symptoms, but it could definitely happen. Okay. Moving on. So what we can do as a community to flatten the curve? Are you flattening the curve? So what we can do as a community, we can do certain things like social distancing. So quarantine yourself, stay home, self-isolation, wash your hands frequently, disinfect and clean surfaces, and keep distances of 6 feet apart if you are in public. We have another. Oh, Erin. Oh, Erin, thank you. So my question, are you flattening the curve? Yes, good job. And here we can see that avoid close contact with people who are sick, or cover your cough or sneeze with a tissue. Avoid touching your eyes, nose, and mouth. And clean and disinfect frequently touched objects and surfaces. Stay home when you're sick. And when you wash your hands often with soap and water for at least 20 seconds, no less than 20 seconds, at least 20 seconds. And here we have a small activity we're gonna do. So when I used to volunteer at the Kaiser, this is what I learned, and taught for my volunteers. So what are we gonna do all together? I want you guys to practice that as a future healthcare professions. Are you guys ready? So number one, you get the 2 pumps. For example, we already got those soap, and we try to rub, yay. Then next step, between fingers, and you do, yep, because you trying to get rid of the germs between your fingers. The third step, you 2 pumps, one on another one, and you just rubbing, yep, and then you the other hand, yep. Fourth step, it's thumbs, and you go and you, yep, yep. Then back, you go, one right hand on the top, left on the bottom, and you lock the lock, and you wash it here, yep, perfect. The sixth step, 1 palm, you take your fingers and you rub on a palm. So while you're doing this, you want to get rid of the germs under your nails, and then you switch with the other one, with the other hand. And 7th step, you try to get out of the wrist, right? Perfect. And then you just wipe it. Good job, guys. So you guys learned the best technique to prevent the spread of the virus, any virus. And there is another tips, we call it do the high five. So to help stop coronavirus. So first, it's hands, wash them often, at least 20 seconds. And we learned the techniques. 2, elbow, when you cough, try to cough into it. So that's how you're supposed to cough, right? You don't cough and spread all your viruses in the air. Yeah, you cough here, perfect. 3rd, face. Do not touch it. Do not touch your eyes. Do not rub your eyes. Do not touch your nose or mouth. 4, space. Keep safe distance. It's a 6 feet apart, right? And 5, home. Stay if you can. Quarantine yourself. Isolate yourself. So remember those 5 tips. I5. So today you can do this 5 step. Do the 5. To flatten the curve. That's your duty as a community members. And I think we have a quiz time. Yay.
Yeah,
Joey,
I think you can click the poll
oh, where's the,
on the bottom. Sorry. If not, we can probably skip this one because Erin was supposed to be the poll.
You're supposed to.
Sure.
Oh, do you want to read the question maybe, or type in the chat? If you want to.
Let me figure it out real quick.
Do you guys have any other questions?
Oh yeah. Any other questions for Mia?
And if I don't know the answer, I promise I'll do my homework today, and I'll provide with the answers. I think Erin's supposed to be a poll, but
yeah, okay.
That's okay.
Let me put the quiz question in the chat so it
okay, that would be awesome.
Have to go old school, not really old school.
Yay.
So the question is, what is social distancing? And then there's 4 different choices. So if you want to, you can put your answer in the chat, or you could say it. 4, another 4, all 4s.
Ooh.
Okay, yeah, that was my question, but did you have anything else to add, Mia, before we continue?
No, pretty much everything.
It's not that much though.
Yeah, I mentioned everything that, yeah, on the presentation, but if you guys have more questions, feel free to shoot the questions. I'll do my homework, and Joey will email you the answers later.
Yeah, I think we have a couple more slides left. Do you want me to?
Yeah, go for it.
Okay, and then Can you hit the next slide?
Sorry.
I don't have the
Oh yeah, that's
Zoom,
okay.
the presentation online. Okay, so I know we have a couple minutes left, so I'm just gonna touch briefly on this, and this is just like for general recommendations on how to cope. So if you ask me, my coping mechanism with this was going up and down, because for me, I'm an introvert and an introvert and an extrovert, so I kind of want to talk to people outside, but I kind of want to stay in. So it was like half and half for me. So each person is different. Some things we can do to cope would be establishing routines. If you usually study or work at home, you kind of have a routine down, either it be working in your own room, working in the living room, kind of just making a structure and a setting so you can be productive in that. I like to do it in my room, but to avoid going back into my bed, I kind of make my bed and make sure that I don't go back, so that you don't go into like your sleeping mode habits, because I've been doing that for the past week. So I got my structure down. Being active as possible. Probably Mia can speak the best for this, because she does at-home workouts. She does her, what is it, HIIT routine. So
Yep.
go ahead and ask her. Also finding a new project or activity. I'm sure that we always wanted to try a new hobby, a new project, learn the guitar, and especially doing the things that you always wanted to do but never did. This is the perfect time to do it. You have no excuses. You're literally at home. Communicating and staying connected. So this, whether it be to keep calm and stay informed about COVID-19, other updates that Governor Ige has sent out, and also just communicating with those you love and others that you can't be in physical contact with, but you can also reach out. And especially to those either who you know don't live alone, or there could be a neighbor as well. And then also remembering why we're doing this. What Mia said, flattening the curve and social distancing, those are all things we can control, because a lot of factors during the situation we can't control, and we can feel a loss of kind of hope. But just to re-emphasize, just remembering why we're doing such certain or drastic measures, so that we can keep others healthy. So remembering the why.
Yeah, I want to add that, yeah, it's, I know we're young and we're have so much energy, we have to stay home, but remember, it's not always about you, it's about our community and elderly people and people who has underlying conditions. So we have to care for our community by lowering the curve, flattering the curve, and to do that we have a good tips what we can do to prevent that virus community spread. Thank you, Joey.
Yeah, and the next slide is just one last tip.
Oh, next.
And remember to keep the aloha spirit. I know a lot of you guys are online probably seeing some of the stuff, like either people are being rude to people at Costco or at Target, and just remember to keep the aloha spirit. Everyone is trying to work together as a community to either just be healthy or continuing like from day to day. Just remember to be kind to one another, and you know, if someone, it looks like they're having a bad day, just offer them like, you know, the nicest thing you can do. If like you have toilet paper or if you have like hand sanitizer, just remembering the small humanity and kindness. And yeah, that's about it.